Okay. Paola, can you see me finally?
Yeah, yeah. How are you? You are here, yeah. Slow, you have entered in the video. Welcome, Cecilia. It's the first time, we are the first step in this technology, and the next times we will be very, very strong and rapid.
I hope so. And I think we have Barbara watching.
Yeah.
Yes.
Yes.
Good.
I have
Hi,
changed
Barbara.
something. You have noted that I've changed something. My
Yes,
hair.
I like your hair. Yes, it looks very
Thank
nice.
you. Okay, I say serious right now, but I'm happy you appreciate my new look.
Yeah. No, it's very fashionable.
Oh, thank you so much. It's for this if it's still occasion, if for this event I have changed my look.
There you go.
Okay, thank you. First of all, Cecilia, thank you very much for your patience. You have to understand that my English is not so good, and I have a lot of misunderstanding in this period. But I'm very happy to start to work more deeply on the 3D application in real context, in real ecosystem with you. And if you agree, we can start to have our brief Pausa Caffè on the 3D printing applied to the agriculture. So if you agree, I will start showing through this feature of YouTube Hangout. I try to share with you my screen. Can you see?
Yeah, it's
presentation?
showing.
Oh, okay, fantastic. As you know, I prepared this presentation only to synthesize the thing that I think is important to point it out during our discussion. This first map is a way to describe all the component, all the complexity of the 3D printing technology. When we decide to approach 3D printing technology for agriculture, we have to consider that we have different type of material that we can use to create 3D printed objects. And these materials are strictly linked to the engine and to the process that we can apply. Thanks to your analysis, we can discover that we have technology, materials, engines, and process that are not sustainable, that are not green, because use dangerous materials like solvents and so. Other are sustainable technology, use biomaterial, recyclable materials, and we have to select only this kind of technology for agriculture, because we want to go in the direction of green manufacturing. Cecilia, do you want to add something, information about that?
I think what was interesting as we were delving deeper, when we talk in manufacturing about the prevalence, or in sustainability about the prevalence of dangerous chemicals, it's not until one's looking at the materials that one realizes it's easier to make a list of what does it, that one expects to have a long list of options, and the more one looks through and looks through and looks through, the list of options gets smaller and smaller and smaller. And as you know, we were talking, the PLA materials are the ones that sort of are the best right now. And then when you take them through the tolerance test and the durability test, they're failing on that. So you're sitting there going,
Yeah. No, yes, this is very important, because we have, sorry.
No, go ahead.
No, I agree, because this is the very big issue. We have to select and decide what are the right technology to guarantee a sustainability for the environment and also for the people that decide to use this kind of technology.
Yes. And I think what I like about the way you're bringing this together, especially with the 3D printing, is before, let's say we were working in a big factory and we wanted to test these theories out. I mean, we'd have to fill out the whole giant vat of a material to see, to be able to see what the output was in order to test the durability and the reliability and all this. Now we can just, program it in, test the material, put in, I mean, there's still waste in the process because the extruding process is wasteful, but we're wasting like maybe this much instead of like a whole vat full of material to test one thing, and we can do micro tests. So from the Lean Six Sigma perspective, where you always, and the permaculture perspective, where you do small testing and small testing and small testing until you can know the result before you scale it up. The 3D printing tool is very powerful.
Great. Another consideration, and I return on our presentation, is regarding to the business model that we can use and apply for using 3D printing in agriculture. And also we can consider that we have a lot of applications that we can implement through 3D printing in medicine, in several sectors. But in my opinion, agriculture is really interesting because it's the more, let me say, in my opinion, is the field in which are based all the emerging economy. Agriculture and the independence in agriculture is for some country a very strong opportunity to be more strong in relation with other Western, for instance, country, more strong than and that sell a lot of product. If we are able to start with a very simple solution in agriculture, I think we will be more simple to develop a self-sufficiency model. And so my first consideration and about the 3D printing application in agriculture are classified in 3 big clusters. The first is to produce machinery for agriculture. Here you can find some example, or tool and elements for customize the farms, and also irrigation system, hydroponic, pottery, and so. But why? What is the question that more of my customer ask to me about 3D printing solution in agriculture? The question is how farmers can approach this technology, because right now is expensive, it requires more knowledge in terms of technology, and so it's not so simple to implement. So we have seen 3 different kinds of models: the make model, the buy model, and a mix of these 2 kinds of business model. So I think that the make model required a very high level of knowledge by farmers. And right now we have we have found 2 examples, but a lot of documentation is available online about solution for agriculture. Open Source Ecology is a very interesting organization, a no-profit organization, because in this website they share a lot of important information for farmer interested in implementing these solutions. And also they provide consultancy online in order to support who is interested in. 3D Ponic is another profit company, but very interesting because they mix the innovation in 3D technology with hydroponic innovative technique to produce food. So, Cecilia, about this very deep consideration, do you have some information that you want to add, or I don't know if you want to some question or need by your customer that we have investigated in this kind of business model?
Yes, we're working, and it's going to be a slow process. So those watching know that it might take maybe 6 months before we can even show progress, because things work differently. But we're working in Kenya, and we've got support of universities, University of Nairobi and Bondo University. Right now, it's not an official university level official collaboration, just personal contacts that have shown interest and are willing to lend ideas and are listening to the idea. So, know who versus know how. This is the know who part of the project getting started. And the issue, so what we're looking at is what is the simplest type of tool that we could begin to develop on a 3D printer that a farmer it would improve the farmer's ability to create a yield, but it would also give information for scientific analysis. So we've thought of a 3D sensor, a 3D printed agricultural sensor, so a soil sensor, and you can make them, they're about this big, and looking at how farmers could not only create their own sensors and then use them, but then see how a system can be made for sending the information on soil conditions up to the cloud, so to speak. And then this data can be shared and analyzed, and technical assistance feedback, remote feedback, can be given to a farmer. So from a commercial business model standpoint, This is sort of in pre-alpha state. um,
It's a good imaging, a pre-alpha, zero, the zero stage, but yes, initiation stage.
um, one of the, in terms of what we're thinking in market, what we're having to realize is convert. For example, here in the U.S., you say, a $5 component is cheap. But if we're dealing with farmers who make less than $2 a day, and what we wanted is to have the percent equivalent to salary of a $5 component, all of a sudden that $5 component became cost prohibitive. So, we're scratching heads because the input materials don't change. And now we have to figure out, if we can't get a quality piece down to quote unquote lowest cost, what kind of business model can we develop that makes this product at the lowest possible cost we can develop it, affordable to um, people within that income? Because instead of looking at it as poor, just looking at it as a whole different income segment that we've never designed for. So, like in business, it's a challenge where it's a whole new segment, and we want to see how this works.
Yeah, yes, of course. It is important to maintain the approach of the experiment. Try, error. I mean, no big error, but we have to try and to understand what is the best way, and to adapt a model, a system to the different reality, of course. And coming back to our guideline, let me say, we have another model, but the issue of the cost for farmer of this kind of solution is already an issue. But anyway, we have the possibility to buy some tools and some element through different way. The first is to buy a 3D printer. Of course, this is not a realistic solution for several farmers. In this way, they can make their tool, their accessory, but this is an expensive solution for several farmers. Another solution, more cheap, is that farmer can choose or design directly his tool accessory and buy 3D printed object for a 3D service provider. Right now there are a lot of services of course, in US, but of course in Europe, in Italy too. There are several companies that provide the 3D printing like a service. If I need to have not only for the prototyping, but also for an object. For instance, I would like to build a little home for explain to my little guy how to design a home. Okay, I can buy this model via 3D printed services. It's more cheap, but it's not a realistic solution still this. The model that we have shared and in which I would like to have your opinion about is the collaborative manufacturing applied to the agriculture. In this idea, manufacturers, 3D printing services, farmers can organize a peer-to-peer collaboration. Consider a little town, for instance, in US or in Italy. In this single town, for instance, Lodi, near to Milan, is a little town that has a lot of farmers and ranchers, okay? But in this little town, we have also system integrators, are small company with professional interested in 3D printing, in CAD modeling, in finding innovative and sustainable solution. Then in Lodi, there are also manufacturers of biomaterials. And they are interested, of course, to understand the development of 3D printing in agriculture. Other can be designers or service providers or 3D printer manufacturer. If these different, let me say, cultural dimension, knowledge dimension that any little town has, can organize and add their competencies in a unique organization, small organization, I think it will possible to organize a small ecosystem concentrated in developing solution for agriculture. What is your opinion about?
Yes, the idea has been well received so far on the Kenyan side.
Right.
The challenge, of course, like a lot of times with African projects in rural Africa, is infrastructure. You'd already mentioned the cost of the printers, so there's a need for I guess in the West we'd call them 3D printing hubs. So if a farmer can't get to the 3D printer in the house, they could go to like here in the US, we have like a Kinko's or a central kiosk that has the 3D printer, and people can collaborate and they can sort of make things together or pick them up together or things like that. There are hubs spreading around Nairobi. They haven't reached the rural areas yet. And that's part of the reason that we are looking to work through universities, because that's where equipment is. So, and also technical expertise.
Yeah.
Like any new technology, um, until it's sort of like a science fiction mythical thing until people start touching it, playing with it, and feel that there's an expert they can ask questions of and turn to for support. Like you and I have been going through as we look at like, okay, which machine and where do you put the filament and
Yeah.
and how does it work and
Yes, because it's very complex. So, we have a lot of different point of view from which we have to understand the problem and find solutions that are, let me say, balance all the elements that we have to consider in this kind of solution. It's not a way to simplify the problem. It's the way to collect different competences in order to solve in a very quick and open way the problem that we have right now to analyze. But I think that starting from, for instance, in this our first conversation about 3D printing in agriculture, from my point of view, my vision is very an eye level, still in the eye level of problem, a philosophical view of the problem. But I am very interested in the next our conversation to reduce the scope of my vision and start using this technology and provide different way in which we can use it without having a very high level of competencies in technology, in chemistry, and whatever we need to implement this kind of solution. But in your idea,
CAD design too, because that was another issue that came up. If you've never done CAD design, yes, I'm hearing that now you can take a picture with your cell phone of what you want and you put it in and it does it. But if it's an object that's never been created, you can't take a picture of it. So
Yes,
the
it's
creative
true.
process is limited. Learning CAD design skills is another challenge.
Yes, this is a very important, of course, it is a very important skill. And also you can consider that in this case, we can start downloading 3D components and models that are already available for free on the web. There are a lot of community that provide for free a lot of very interesting model for making tools and accessories and spare part. And we can think about organizing the reverse education on the CAD engine. Let me explain better. If I don't know AutoCAD, I don't know any other CAD systems, but I'm able to download a 3D model from web, save it on my UPS key, go to the 3D printer service hub and print this model and use and understand if really is good for working in my factory or in my farm. Then I can decide to understand if I can modify the standard model that I have downloaded of my from a website, and I try to learn CAD system. I don't know if this could be an interesting approach, but maybe if I have to organize CAD education, it's very expensive. Maybe it's not interesting for the attendees, for farmers, of students, of young people that want to learn. If I use a real file, a real object, and people try to adapt and change them, could be more interesting. What do you think about?
I think that this is now, like you're saying, in the US slang, we're getting to the meat and potatoes. We're getting to the essence of the issue.
Oops. Oops. I agree.
Because AutoCAD has some very sophisticated tools, because the other component is also the materials analysis, which is the high level scientific analysis part. And we haven't even talked about the sourcing, the supply chain sourcing, how to train people to source the right material. But AutoCAD does have analytical tools where you can, I don't know if it's 3D environment or whatever, but it does have a tool where if you have a part and you're trying to think about what to do with the substitution, you can take it through the AutoCAD and it can give you the recommended alternative plastic, and it gives you a cost output. But of course, that is very useful for an experienced designer, an experienced engineer who already knows all the background material, knows the tolerances, knows all the issues. And all you need is a tool to help you take a quick snapshots at substitutes. If you have never manufactured, you're in a rural area, you need equipment, you've never manufactured anything in your life. This is the first time sitting in front of a computer with a CAD, and you're like, a what? And
Scary. Yes. Yes,
culture,
it's true.
English is not your first or second language, and now you have to figure this out. And on top of that, somebody's saying, get the sustainable material right. So what I like about your approach is that we're not coming in with a preset formulaic process. We're keeping focused on the goal. This is what we want to create. This is what we want to design. And we're putting it out there and we're getting feedback from from the different culture and ecosystems in which we want to bring together to work, and letting them talk about their reactions, and then we respond and we think, and then we put something out, instead of trying to drive, this is the best practice process. um, sure, probably in 5 years, maybe there can be some lessons learned that could be quote unquote best practice that would help others, that say, oh, don't ever try this again. Or it worked really well. um, but it's not sort of a rigid, this is what you have to do type of best practice approach. It's more of a fluid, this worked, this didn't work, sort of shortening the evolutionary cycle. I think that the ability, that what makes humans magical over machines is, you program a machine, it has to follow that path. A human can decide that's not the best path, or I can change this path as I'm following it, and that's the beauty of
Exactly.
human. And
Exactly.
we
Yes.
can't get. So this is pretty exciting.
Yeah, great. I agree completely. So, Cecilia, if you agree, I have we can close this conversation pointed out only two references in order for people that who is interested to see this video and to understand and learn more about these topics. I prepared a last point of reference because, okay, today we have make an overview on 3D printing applied in architecture, but if people want to join us to understand and learn more, I think will be interesting they join to Collaborative Business Network on Google+. Cecilia made this community 2 years ago, and we here have already collected a very an interesting quantity, a high level of materials on several topics. 3D printing, of course, is our last interest and very strong interest. But we have also information about collaborative manufacturing, permaculture, open cultural system. So I hope people will join us on this group. What do you think, Cecilia? Do you want to close with your fantastic smile this our conversation of today?
I just want to put a vision out there that's circulating from Homa Bay County. So I'm just, being a parrot on this. What they want is they call it an agri-city. So a city that is agricultural. And how do you build a city, like an urban city, but it's all agricultural. So that's their vision for what they want in Homa Bay County, so that others understand, like, are they really doing this by themselves? And who even cares about what they're doing? So there is a master plan created by others that we're trying to help, and we're trying to find a way to add value to that process.
Yes, of course. Okay, Cecilia, thank you very much for your contribution and for your approach. I'm very happy to collaborate with you, and in tomorrow, I think, or maybe on Sunday, the video will be available. If I don't know if I will be able to cut the starting and some error during our discussion, but in the next few days, I will make some adjustment to our conference call.
One of the things that this process, people are, the little feedback I have is that they're enjoying the mistakes. I think sometimes we, as professionals, we're so used to, like, let's make sure we show, when we got it right. And I think people are enjoying seeing that sometimes we don't get it right.
Okay, I appreciate. Yes, I agree. okay, if you want, the video remain the same. Okay,
Yeah.
with the error, with mistake, with my bad English. Okay, I agree with you.
If you ever want to feel better, try and have an interview like this in Italian. I'll be able to say 3 words, and then I'll be like, "Mm."
Okay, thank you. I appreciate your compliment. Thank you very much. Okay. So, thank you very much. Have a nice day.
You
And,
too.
okay, see you soon. Ciao, Cecilia. Ciao, ciao, ciao.